Alright everyone, we are going to go live soon, so be ready and hold tight. So that's all. Thank you everyone.
Stand by.
Okay, so I've already opened just for you guys to hear from the NASA stream after all, so should be good. Alright, so maybe I can go now and like
Station Houston 2 for HTV-X. HTV-X is ready to proceed to the capture point.
alright.
Expect approach to resume shortly.
Alright, so that's all. That's why I've already closed the music so you can hear it. That's the call out, and let's go.
We're handing over
And
between satellites.
yeah, and hello everybody. This is Suguwa, and wherever you are, good day.
Station
At
Houston
least
2
for
for
me,
HTV-X. HTV-X
right now
is ready to proceed to the capture
we
point.
almost meet up
Expect
here
approach
around
to resume shortly.
11:23 p.m. here, local time here in Sarawak right now. So
Copies.
So let's go.
Capture point. Expecting
approach
to resume shortly.
okay. So I think maybe we can go a little bit with what's happening with the capsule, right? Right now with the
So with that,
HTV-X1.
Yoshide informing
let's go.
Zena Cardman that
So this is
the
what I am
vehicle
going
is
to
ready
show,
to
but
resume
we are going to
the
do this
final
one by one.
leg of its
This is how the
three and a half day journey
HTV-X
to
looks
its
like
capture point just
when
about
in
10 meters
conceptual
away from the
around
International
2015,
Space Station.
which eventually they go with a little bit like butterfly, bird-like design on
And the approach command
2017.
has now been sent.
Okay, and looks like approach command has already
HTV-X
done.
and space
10.
station flying
So
just off the west coast of the United States.
alright, and it should be good. As you can see, this is now the approach authorization should be good.
Station Houston 2 for HTV-X. HTV-X has begun approach from 30 meters.
Alright,
Monitor per step 7 and 1.102.
alright. So that's what you have heard right now. And so far for the
resuming the approach and monitoring per step 7 of 1.102.
alright, so looks like it's already resuming its approach and we're going for the final approach. If I remember correctly, this is around 30 meters from the International Space Station there. You can see there. With the grappling hook you can see there, that's
The
down to
capture phase.
yeah, that one is
involves
the
Kimura
evolution.
Yui operating
Let's just
the
say like an
station's robotic
evolution
arm
from the original
from the cupola,
down
backed up by
origin launch
NASA's Zena
around,
Cardman.
if I remember, around the time where space shuttle used to
The
launch
end
to.
effector
And you
will
can see
move
this
over
is how
the
it looks
grapple
like
pin.
there.
It will actually
And
grapple
you and
HTV-X,
I can
but
give
the
you a little
snares
bit of
then will have
details
to
here.
close the carriage,
If you
retract
see
it,
from the
and that will mark the
middle
official
around
capture
the solar
time that
panel
we'll
area there,
provide for
in
you
the
as soon as
middle,
we have that data.
in between these two solar panel, that one is the service module, anything that's whatever is inside there, and on the on the bigger head like let's just say like a big bulky head there, on the upper side there, the upper side you can see, or you can see it on the right side here on this view. Looks a little bit bigger there, bigger than the rest of them. That one is the pressurized cargo there. There it can just put out whatever it wants there. For example, maybe if this is something to do with the oxygen, maybe you want to go there a little bit for sleeping and whatnot. That's where pressurized cargo is actually for. Especially very important if you're dealing with the pressure, with the different differential pressure in between the International Space Station and the space
HTV-X
and
closing in
capsule
at a
there.
very
So
glacial
that's why it's very
pace,
important. You can see there,
some 28
and
meters
also
away.
in the bottom line there, they're not really that big. Let's just say it's in the bottom, or like a little bit bigger there, but not really. That one is uh, that one is the unpressurized cargo, if I remember correctly. That one is unpressurized cargo. I think, yeah, I wish it probably captures anything in Mars, but whatever. That on the most left side, just after the solar panel into this view, that one is the
27 meters away.
unpressurized cargo that will basically just house whatever not really super duper important. I mean, it's still important, but not as too important as the pressurized cargo there. That one in the unpressurized cargo, technically you can also use it as a platform to do whatever you want. You want to launch, you want to put payload there, you want to put satellite there, so you can deploy straight from the international space station. After that, that one is very important. Part two, and you can see how it will capture Canadarm 2 will be captured around the service module area in the middle, in between these two solar panel there. So that's how it works there.
Station on 2 for Block Bravo.
Oh,
Lights have converged on the center of the circle, and circle has converged on the center of the corridor.
yeah. So look like
Copy, good
converging.
report, thanks.
Yeah.
This view now from the end effector camera on the station's
If you hear a
Canadarm2
little bit like
robotic
the
arm.
light converge, whatever, something like there.
25 meters separating HTV-X
All
from
right.
the arm.
25 meters from the Canadarm 2. Yeah. From the nearest point of the International Space Station object, per se, we can say. So that's where now where it's right now, and I believe it's going to be around 20 meters next as the milestone. So that's that. You can see it's a little bit. It's pretty interesting. I can say it's not little bit. It's still pretty interesting. It's inching one by one, and yes, even every procedure. Usually, when you try to approach International Space Station, if I remember, starting around a kilometer or 100 meters like that, that's where they will stagger this one by one approach. Okay, they, if I remember, there's up until four bubble station, if I remember correctly, like the four phases final approach. They start around 100 meters, and then if I remember, around 75, 50, and then the most final approach is around 30 meters. So that's why I remember, and then that's where it leads to us today. Yeah, that's where it leads to us. So you can see there, it's looking pretty nice and pretty beautiful there.
23 meters now separating HTV-X
All right, 23
from the
meters.
International Space Station.
Yeah, 23 meters for sure, or 20 meters.
Just passing south of Baja, California, moving from northwest to southeast.
Alright, just passing from Baja, California, apparently. Baja California, United States, of course. So that's that. And to anyone that's watching here live or maybe replay, hello, hello. I hope you guys have a great time here. Just enjoy wherever you are, even if you don't open and watch this stream or even this replay physically, you can still hear this, and I'll try to explain as much as possible. And looks like it's still inching pretty closer and closer and closer there. Could be 20 meters from now. And alright. And speak about the light converging there. If you actually see from the live of around few hours ago, there's actually the indication of the light, if I remember correctly. Yeah, if you see, there's like there's like dots of lights there, like a three lights there. That's basically what it does means with the light converging there. It's like the most important part, the sensors to detect here and so forth like that. So basically, as a like a sensors to measure the distance in between.
This is Mission Control Houston. Everything continuing to go very well as HTV-X is about to close To within 20 meters of the International Space Station, you can see the Canadarm2 extended, ready to move in under the command of Yui, operating from a workstation in the cupola, backed up by NASA's Zena Cardman.
Alright, so
that arm will be set in motion once HTV-X arrives at about the 10-meter mark.
alright. So just what I want to, how do I say? Just what I would like to continue with my talk here is that the light converges, as you can see, with these three dots there before, previously in the stream, previously in the few hours of the NASA stream. You can see this is from the view. Okay, the three dots there. That's basically to measure the distance in between from the HTV-X1 to the International Space Station, and specifically the Canadarm to here in the grappling hook you can see there. That's basically to measure distance. If I remember correctly, there's few methods. One of it is to calculate it to using the laser stuff here, or you can also use ultrasonic if you really wants to. Basically, where it tries to measure, it just basically like shooting up the ultrasonic, aka the laser, whatever inside the instruments. It tries to shoot from the from the space capsule here to the International Space Station, and it will try to calculate itself autonomously in real time. So that's how this HTV-X1 does its calculation here. Yeah, I mean, it's very simple and super rudimentary what I'm going to explain here, because yeah, even if I try to explain, there's no 100% how do I say, no real 100% easier way for me to explain this without throwing everything out of the curve. Anyways, so that's that. You still can see still inching closer and closer, and looks like the camera exposure looks like already going down a little bit there, just for the measure. Yeah.
HTV-X continues its methodical approach towards the end effector of the station's robotic arm.
Yeah.
Just
So
17 meters separating HTV-X from the capture point.
all right, and as you can see, that one is the capture point on the, that looks like, how do I even describe this properly? That looks like something like three lines, which were separated around 100, I guess 120 degrees apart in between these two, like in circle. There's like, how do I say? Well, just to be easier, try imagine this is like the uh, Mercedes Benz logo, but instead that one is for the grappling hook, if I remember correctly. Yeah, the grappling hook uh, around the service module of the HTV-X1. You can see there. That's how it will be captured using the Canadarm2 real grappling hook from the ISS there. And of course, this one actually were remotely piloted by JAXA's astronaut uh, Kimu how
Once HTV-X has been
Yui
grappled,
Kimuya, if I remember correctly.
Yui and Zena Cardman will hand over the
Yeah,
robotic
okay.
chores to the robotics officer in
Kimia
the
Yui
Mission
and
Control
also
Houston,
Zena
who
Cardman,
will spend the next
Zena
several
Cardman
hours
from NASA,
maneuvering
of course,
HTV-X toward the
piloting together,
Earth-facing
and
port of the Harmony module for its
like,
installation into the common berthing mechanism on that nadir side of Harmony, where HTV-X will then be bolted into place.
yeah, if I remember correctly, also this flight also they also carried one of the important technology demonstrator here. One of it is the Mount Fuji, if I remember. Yes, not to be confused with the real life Mount Fuji in Japan. This their one is also Mount Fuji for the instrumentation to
The crew will
to
not be opening the
experimentally
hatch to
test out the
HTV-X until tomorrow
automated
morning
system to
to begin the process of unloading
mm,
the start of the cargo operations. Some 4.5 tons of supplies and experiments arriving at the International Space Station.
yeah to actually test out the exactly for this one for the distance measure and also to test out a little bit newer technology here and there. So that's why it's very important. uh, Mount Fuji is one of the experiment. And if I remember, one of the modules that's also reused in this HTV-X1 and also as HTV-X in general is the ISIP platform, if I remember correctly. That one
HTV-X and the
they
station
reused it
flying
back
from
from the
northwest to southeast
HTV the Conatory one. They basically
over
reused it
the
back here,
Pacific Ocean, just
but
off the coast of
modify it
South America.
to modernize it, of course. And I and basically it's like a little bit surplus, so they can so they don't have to recertify too much of the hardware other than just to see if it's compatible. That's all. So that's why. And also I need to also tell you that while the diameter of this HTV-X1 and HTV-X in general is pretty much the same with the previous
Now just 14 meters
HTV,
separating the two
the
vehicles.
Conatory one, the original one, around 4.4 meters. Hence why we see the rocket configuration for the launch configuration of this one. It uses H3-24W. The W white basically they have to use the 5.4 meters of diameter instead of typical 5.2 meters available on the short and also long. And but the length literally it's still the same as the uh, as the as the long one. That is 16.6 meters if I remember correctly. Yeah,
About 5
but
minutes away from
but
arriving at the capture point.
but the but
One
the length
final
of
check
this
of HTV-X's
HTV-X
systems
is a
before the
slightly little
approval is
bit
given for Kimmya
different
Yui
in
to begin
comparison to
extending the Canadarm2 toward the grapple fixture.
it's a little bit different in comparison to the HTV to the original HTV Konotobi one. For the Konotobi one, it's the length is 10 meters, but however for this one it's 8 meters. So that's a little bit of difference there. And because of that slight difference of 2 meters, they are able to slightly reduce the weight, even the total mass weight that can be loaded amount of that can be loaded inside the spaceport itself. So, for example, if before they have to use HTV Konotori, they fully loaded, it will be around
13 meters now
16.5
separating
metric tons.
HTV-X
But
and the station.
however, they are able to shave around
Everything
500
looking very good.
kilograms, which
HTV-X's
the max
systems rock
itself
solid.
will is 16 metric tons.
HTV-X and the
And it's
International
like
Space Station flying
while it
just
sounds
off the
like
coast of Peru.
too much, how do I say, while it sounds like too much cut down version and whatnot, but I guess on on the good side, what does this means that they actually surprisingly they can load even more, even let's say more payload, whatever is it, while reducing the unnecessary dead weight associated with the previous HTV Konotori origin design there. Yeah, and you can see something that looks
And
like
a good view from the
replica
end effector
of the
camera on the Canadarm2
Mercedes-Benz like
as you're looking
stuff
right
here.
down the
You can
barrel
see.
of the grapple fixture that the Canadarm2 will affix itself to here a short time from now.
Yeah, so you can see that it's pretty good. Almost closer and closer and closer and closer. And yeah, I would like to change that. I would like to change into the NASA spaceflight forum to discuss a little bit about this HTV HTV-X. But however, looking at this situation,
The
I
journey of
believe,
HTV-X that began 3.5 days ago with its launch atop JAXA's H3 rocket from the Tanegashima Space Center in southern Japan about to conclude. Now just 12 meters separating HTV-X from the grapple fixture on the International Space Station's Canadarm2.
alright, this is slow and meticulous process, of course. And yeah, looks like based from my timing, it could be 8 minutes from now, or slightly a little bit longer, or could be shorter, plus minus like that. And then after the capture, it would be birthed. It would be birthed later to the Harmony Nadir port. Yeah, so that's where they finally it will be attached together. Where they will be attached together until the time comes. And also, yeah, where do I stop here? Whatever. And um, talking, speaking about this one, okay, there's also one additional capabilities that HTV-X can do what the HTV Konotori version cannot do. You want to know something? It actually can just, even after departure of the ISS, it can maneuver itself going to a little bit higher altitude, so it can also deploy other satellite there uh, to do whatever it wants. Maybe it just wants to do something else, whatever profile mission. If I remember, a Tenso something, Tenso dash one, if I remember, that one is still attached.
Station Houston on 2 for HTV-X. Confirm capture point hold for step 8 in 1.102.
Alright. Looks like it's staying a little.
Houston Station, for step 8 of 1.102, we can confirm CP hold.
Alright. Looks like hold.
Houston copies.
Okay, so looks like hold. Maybe we
This
can
is
change
Mission
it.
Control Houston. Aki Hoshide confirming with Zena Cardman that HTV-X has reached one final hold point at the 10-meter mark. Now polling the flight controllers for a go, no-go to resume
Alright, 10
the
meters.
operations that will involve Kimiya Yui extending the Canadarm2 from this 10-meter mark to the grapple fixture on HTV-X to complete this rendezvous.
Alright, so to resume back where I actually left. Okay, so the capability that this HTV-X can do is also to deploy satellites after it departs from the ISS. That's also something it can do. If I remember, there's one satellite, the Tensor one, if I remember correctly, it still will remain attached until it departs from the ISS. Okay, around 30 plus days from now, if I remember correctly, and then it will be deployed around 500 kilometers, and then this HTV-X will be will will rented pretty destructively to end its mission around the,
HTV-X is about to be
let's
placed
just say,
into what
around
is
the
called
Point
free
Nemo
drift,
area.
inhibiting
Point
any
Nemo
further
area is
thruster
basically like
firings
the
so as not to
imaginary
perturbate the operation
point
of
of
the
the
Canadarm2 robotic arm as it moves
of
in to
the
grapple the vehicle.
Pacific Ocean, where basically 99.999% guarantee there will be no wildlife, no wildlife, mostly not going to be to harm all of this if it's destructively oriented. So that's usually they will just go and re-enter to the Point Nemo basically. So that's how it does. Okay, and since we are still holding, why not let's go and learn a little bit about this HTV-X. We are going to learn together, okay? So yeah, so originally they actually conceptualized this one as the HTV-10 back in 2015, which was announced by the MAX, aka Ministry of Education, Culture, Sports, Science and Technology, where they aim for the 50% cost reduction. You can see there. This is how it looks like. Originally, it looks, if I can, if I have to be honest, the design, uh, the center core, the tube-like design here doesn't really change too much from the design that we see right now. Yeah, it doesn't change too much except that solar panel not really looks like pretty glamorous like what we have right now here. Like
Station Houston 2 for HTV-X. PVGF SEP is enabled.
yeah,
Prepare for capture per step 9 in 1.102.
okay, so they're ready for the next step because they're a little bit
We
hold.
see PVGF SEP is enabled, and we are working step 9 of 1.102.
All right,
Houston copy.
looks like they're proceeding here from the call out we are hearing there they are enabling this step 9, basically the final step before it will be captured by the Canadarm2, which are remotely piloted by JAXA's astronaut uh, Yui, Yui Kimura, if I remember correctly, the name itself, and also the NASA's astronaut Zena
Houston
Cardman.
Station, per step 9, we can confirm command panel LED configuration is good, and our capture preparations are confirmed. We are ready for HTV-X capture with a preference to wait until the other side of this S-band handover.
Alright, looks like the LED already confirmed works.
Copy.
I presume around the
And
HTV-X.
Houston copy. Stand by for capture.
Alright, and ready. Stand by for the capture, it says there.
The S-band handover referred to by Zena Cardman is a brief gap in communications voice-wise. We do have solid downlink television capability.
Alright, so
we're just a couple of minutes away from Kimiya Yui beginning the work to extend the Canadarm2 robotic arm
yeah,
for its
Kimiya Yui.
capture
Haha.
of
Correct.
the Japanese cargo ship
Nice.
that is completing its maiden voyage to the International Space Station.
You know why? Because I confuse a little bit
HTV-X and the station
Kimura and
currently flying
Kimiya.
over Argentina
Just a little bit because
from
it's
northwest to
a bit
southwest
closer
in an orbit
closer in
inclined
terms of
51.6 degrees
pronunciation.
to either
So
side of the equator, about to emerge
so I'm a
off
little
the
bit
east coast of South
hesitant
America over the South
to pronounce
Atlantic.
his name because I don't want to mistake there. And
And
also I
Station Houston
presume
on 2 for HTV-X Zena. So that
yeah,
that
and
big
also
gap
because
in Optimus, we think that's conservative. It's going to be more like a 4-minute continuation and then a 20-second handover after that.
alright, so that's what we hear. Because
Okay, copy. That is great information. We can, with your go, start working step 4 of 1.110.
Okay, copy that. Stand by. We're doing the
Yeah,
final pull
because-
on the ground.
because you know I need to assume that there might be audience from anywhere else, even from Japan that might happen to watch my stream here. So so if I mispronounce anything, it doesn't matter which one. I'm very sorry it in advance, and also previously before, because sometimes try to pronounce it can try to pronounce some word doesn't limit it to Japanese, could be somewhere else, can be tricky. So I always try my best, but yeah, even though at this point try to pronounce Japanese name, or basically Japanese name, Japanese spelling, or literally anything that's basically focused more on the vocal based spelling. Usually pretty easy for me to pronounce it. So that's why I can do whatever I can. But again,
we're in that
so
brief
in
handover
advance
in
if I
S-band
do any
communications.
mistake.
But
So,
the
yeah.
approval has been given
Alright, so
for
approval
Kimiya
has
Yui
already
to
been
begin
given.
the work with the Canadarm2 robotic arm to
JAXA's
extend it slowly
astronaut Kimiya Yui
and
can
methodically
proceed,
toward the grapple fixture on the vehicle.
and NASA's astronaut Zena Cardman basically will like tries to assist assist him on capturing these two. So these two both basically piloting this together. So, but I don't know how do I say if the best way how do I give this this real life analogy, it would be like if Kinya Yui right now would become the captain while the while Zena Cardman became became how do I say the captain office or something. How do I even pronounce it properly? Maybe the easiest way, let's just say first officer or flight engineer, whatever it is. It's like that. It's like that if we use this real life parable here and there. So yeah, and yeah, still holding, even though they are ready to proceed on the next step, the step 9. So might as well let's go back again. Let's see. So yeah, yeah, and also back in the day, around 2015, when they suggest this idea, they are trying to cut this cost by around 100 billion yen, or around that time would be 82 million US dollar, and lighten up the spacecraft by up by 30% around that time too. So so you can see why I said that even on the total mass, the lightest one they are able to shred it off by 500 kilos. Although 30% reduction doesn't seem really that big, doesn't really that much achievable, or maybe already achieved by the time or whatever. So you can see. Oh, okay. So that's the information back in the day, because there's one comment says here by Russian Hello 117 here. This say there has to be in bulk order than that go past HTV-9. These might be left over from now shelf HTV-R program. There is or was a, a plan to fly out H2B and transition over to H3 or TV-X to or H-X, whatever what was it was called back in the day. Back then they don't know what's the plan, so basically that's what the Russian Hello 117 said here. So yeah, okay, okay, not really interesting.
And the International Space Station now in free drift.
The
Thrusters
first one.
disabled.
Okay,
Standing by for arm motion.
okay, standing by for arm motion. So basically, it means that around this point, looks like HTV-X no longer needs to do anything here. It's just stay whatever is right now. So the Canadarm 2 will proceed instead. So let's see this in action.
Houston Station on 2 for your awareness. We are doing translational alignment and then beginning our approach.
Copy, we're watching.
Okay, ready for the translational alignment approach, aka moving that grappling arm of the Canadarm 2 to the towards
And the
HTV-X1.
robotics officer reports the arm is now in
For sure.
motion.
Alright. Alright. Okay, so the arm is already moving right now. And yeah, looks pretty interesting. You can see there. Here we go. It's moving. So yeah, this is now the view of the Canadarm 2.
4.5 meters.
That's pretty interesting, and you can see sometimes
Good view from
a
the
little bit
end-effecting
like
camera.
pressure or whatnot that really moves this. How do I say it? Like
Both vehicles are in
like
free
the
drift.
sheet, something like that. Yeah, that's pretty typical and normal. Don't worry. I mean, after all, this is space, and not everything is 100% perfect. And sometimes there's a little bit like particle, solar, whatever that
Two and
could
a half
mix that
meters.
stuff. Okay, 2.5 meters, basically 2.5 meters. Should be 2. Okay, should be 1.5, I guess. 1 meters.
1 meter away, standing by for capture.
Yeah, 1 meter. Correct. And ready for the half meters. 0.5. Okay, 0.5 meters. And almost closing in. Look at here. Around the marker area. There, yeah, and it was
We
captured
have
by
initial capture. This is
the
soft capture.
Canadarm 2. Okay, soft capture, and
Waiting
get
for
ready for.
snares to close and carriage retract.
Okay, so ready for the hard capture, and but for now we've already have had a capture around 30 seconds ago. Yeah, pretty interesting. You can see the marker there to indicate whether or not it's actually aligned to the capsule itself to capture it, and looks pretty good. Yeah, and looking pretty good. It's already successfully captured, and now there are some few more steps left here and there. Okay, and looks like it. And also from what I can read in the forum comment section comments there, it looks they said it looks like Cygnus with some Cygnus spacecraft from the back then called as the orbital science, and then after that become orbital ATK, and then after that become Northrop Grumman, yeah, Northrop Grumman Innovation, if I remember correctly. That that's basically the spacecraft. It looks like one, they say. I mean, it's interesting, right? And yeah, there's even strap just put up the word Canada there on the Canadarm 2. So yeah, also one of the important uh, country and also partner of the International Space Station here.
Things continuing to look good.
That's also contributing to the mission itself. Yeah, looking pretty good. Okay, and what's next? Okay, and still pretty silent there. But
And we
it's
have
fine.
capture confirmed.
All right, capture really
Capture
confirmed.
confirmed at 10:58 a.m. Central Time, 11:58 a.m. Eastern Time.
Oh, nice.
We have a good handshake between the Canadarm2 and HTV-X. Its arrival at the International Space Station now complete.
Nice.
Capture again confirmed at 10:58 a.m. Central Time, 11:58 a.m. Eastern Time, as HTV-X and the International Space Station flew 260 miles over the South Atlantic.
Nice. That's what we like to hear it. And right now, in my place, it's already 30 October 2025, Thursday at 12 at 12:00 a.m. Yeah, so it's nice. It's midnight here right now.
Thank you very much for your hard work and support for the first HTV-X mission. This is a historic event in the Japanese space program. Spacecraft is so beautiful and shining, and it is representing our future, bright future. Thank you again for delivering these important supplies and experiments. I can't wait to open this golden treasure box. 日本の皆さん、HTV-X 君が無事に ISS に着きました。このミッションを通じて、日本が高い技術力で国際的な宇宙開発に貢献していることを知っていただいて、日本とですね、その国である皆さんにと誇りを持っていただけたら嬉しいです。明るい希望と未来に通じるこの活動を引き続き応援してください。今日は私にこの大役を任せていただきありがとうございました。Thank you very much.
Nah,
Happy capture complete and great words, Kimia. Congratulations to you guys and congratulations to the entire team, to
nah.
all of those around the world who has contributed towards this successful mission. And special congrats to our friends in Japan who has worked so hard for years in development and training to make this dream come true. HTV-X is the 11th vehicle to visit the ISS. Like its predecessor, HTV, and its legacy, HTV-X will be a key element towards our future in space together, in low Earth orbit and for lunar exploration. Once again, congratulations. 日本の皆さん、
Nice.
HTV-X 初号機の ISS 到着おめでとうございます。先代の HTV コウノトリに新しい技術を加えた HTV-X は ISS をはじめとする地球低軌道、そして月までも含めて人類のさらなる可能性を切り開く大きな鍵になります。引き続き一丸となって新しい未来を切り開いていきましょう。ゆうさん、キャプチャーおめでとうございます。Good job.
Yeah, so good job.
Thank you. ありがとうございます。
Good job. And congratulations to
Thank
Japan
you.
for successfully launched their space capsule,
And so that
space
exchange
probe
of
to
words
the
between
International
two
Space Station for the resupply mission
astronauts
there.
representing
Congratulations
the
for
Japan
this
Aerospace
maiden,
Exploration Agency
maiden,
and Kimiya Yui on board the
maiden
station, part of
flight
Expedition
there, and maiden
73,
mission for the HTV-X
relaying
there.
his
For the
congratulations to the whole
HTV-X1
team
mission,
for a
which was
flawless
launched
3.5-day journey of
around
HTV-X
3
from
to
its
4
launch pad
days
at
ago,
the
which is
Tanegashima
very
Space
good
Center
so far.
to its capture
Oh
just
yeah,
a few minutes
and
ago.
which was launched around 26th
Yui
of
operating the
October
Canadarm2 robotic
2025
arm to reach out and
on Sunday,
grapple
or some
HTV-X.
parts of the
He
world
will
would
hand
be
over those
25
robotic chores
October
to the robotics
2025
officer
in
here in Mission
South
Control, who will
there.
maneuver
So
HTV-X
congratulations
to
to
the
Japan for
Earth-facing common
successfully
berthing
launching this
mechanism
one.
on the Harmony
And
module for its installation and bolting into
also for
place
sure,
later today. Those words acknowledged
congratulations
by
to
veteran
basically
astronaut
everyone in
Aki
in
Hoshide
the
here
International
in
Space
Mission Control,
Station
who
control
himself
mission
used the
around the world,
Canadarm2 back in 2012 as
and
part of Expedition 32
contributing partner
to
around
capture
the world
the
for
one of the original
contributing this
HTV
mission. Because
vehicles,
without this,
the
the
HTV-3.
humans' continuous presence in space
So the
and in
work is now
orbit would not
complete,
go
with the exception
not
of the
not going to
maneuvering
be
of the vehicle
very
to its
possible without
installation and bolting
all
into place
the
later today.
collaboration
The
between
bottom
all
line,
of
a
these supporting
flawless
countries.
rendezvous. Everything
Since
went by the
all of
book.
the
All of
mission started around
HTV-X's
25
systems
years ago
performed
in
normally
2000s,
for its capture
the
at
first
10:58 a.m.
the,
Central Time,
the first
11:58 a.m.
which was
Eastern
the
Time,
first step
as
towards the
HTV-X and the space station flew 260 miles
continuous
over
human
the South Atlantic. So
on
with that,
or
we will wrap
in
up our
space
coverage for
or
today.
on
Thank you
in
for
orbit.
joining us this
That's one
morning,
thing for sure.
and have a good day the rest of this day and in the days to come. This is Mission Control Houston.
Yeah, and have a good day too. Thank you so much for watching, and thank you to NASA and also to JAXA for this stuff. And yeah, of course, because I know most of you guys, because this is of course English speaking stuff. Of course, that's why I don't use JAXA stream for now. And yeah, and that was the Mission Control Houston. And let's see if JAXA might still have one. We still can tolerate a little bit other language here, because why not? Why not? That's us at the end of the day. Yeah. Okay. Let's see. Oh, I would hope this is good. Let's go with the JAXA one. Or maybe if they're also already finished with their stuff. Where is the one? Yeah, they clear Usui. I'm not going to disturb her that much. Yeah, let she have her good day there. Because of course she's also very excited and also very hyped, because this mission's also involving her in some capacity, because if I remember, there inside the space capsule there's also her plushies and also stickers that's also on board the HTV-X1. That's one thing's for sure. So yeah, also congratulations to her and also others VTubers that's also uh, joining up for this mission too. Congratulations. That's actually pretty good. And looks like they are still live. Yeah. Let's see. Let's see. Let's see. Hopefully they are here. Let's see.
新しい貨物船が来た時っていうのは中
Oh,
がどういう状態
so
になってる
this
かわからない
is
の
the
で、
currently the
安全
live
な
right now
私たち宇宙飛行士は
around
必
the
ずマスクとゴーグルを
JAXA.
つけますね。
Here you can see. Oh, what a slow laptop. But never mind. I got used to it.
私たちずっと閉鎖環境で生活しているので、そこ
Okay,
に新しい部
that
屋が
looks
一つ
pretty
で
good.
きるっていうの
This one is
も
the
一大イ
JAXA
ベントなんですよね。
coverage. We
な
are
の
not
で
going
いつ
to
も
end this pretty fast.
新しい貨物船の入室っていうのは一人か二人だけがこうアサインされてやるんですけれども、まあその実際にこうハッチを本当に開ける瞬間になるとどっからともなく来る全員こう集まってきてどうやみたいな、おおどうなって早く開けろよみたいな、そんな感じになりますよね。
Right.
でこのアサインされた方が確認して大丈夫だ
Even
って
my
なった後、クルーの皆さん
laptop CPU
どういった
pretty much
状況にな
hammered
るんですか？
down.
みんな入りますよ。
Really need to
待ち
change
に待った瞬
部屋
間
にマスク入りますよ。
at some point.
そっか、新しい部屋ができた。それは大きいです
でも
ね。
最初はもう荷物びっちり積まれてあるんで、もう本当ハッチのすぐ裏側までこう荷物がびっちり積んであるぐらいなんですけど、でもやっぱ嬉しいですよ。
いやーすごい。
Wow.
ではここでもう一度キャプチャーの瞬間見てみましょ
Alright, so this is the replay of the capture. You can see here.
さすが U さんというアプローチだったと思います。もう全く
Yeah.
ブレがなく、
ブレないです。
こう
1 meter
接
away,
近して
standing by.
Looking pretty good
スピー
there.
ドっていうんですかね、それももう全く変化なく、まあ、ずっとコンスタントなスピードで、近づいているので、もうお手本
Yeah, and also this one here is the replay a little bit fast there. You know, it's not this kind of speed. It's pretty slow. Yeah, this is around I think 2 or 3x
This is
of the
soft
speed.
capture.
何度見てもグッドキャプチャーですね。
う。
Yeah, so you can see.
Stairs to close, carriage retract.
Yeah, so this is the replay. Looks pretty interesting, right? That one you hear that sound. That's basically from the NASA live broadcast there, for sure. From the replay
い
you
や
hear
ー
that.
美しいですね。
いや美しいですね。
はい
何度見てもいいですね。
いいですね。
Yeah.
ここでせっかくなので皆さんからいただいた質問ご紹介したいと思います。まず一つ目ですね。カナダアームって給電できるんか、どうやってやるんやろということなんですが、これ内山さんいかがですか？
そうですね。さっきの
So this is a little bit
ロボットアームの
explanation
先
what
端からのカメラでもしかしたら見えた方いたかもしれないんですけど、ちょ
talking
っと
about.
扉みたいなやつが
What Canadarm 2 is all
あっ
about.
たと思うんですよね。
Whatever is it,
これがですね
but I'm not going to
キャ
pretend
プチャー
I
構造
know
的
what
にキャ
this
プチャーした
100%.
後にですね、コ
I
ネ
should-
クターが伸び
I
て
should
くっつくっていう
take up
の
my
が、まあこれカナダアームとその
Japanese
カナダ製のグラップルフィクチャ
sharpen
ー
up
の
again.
機能なんですけれども、
I
そ
can
こを通じて電
For sure, I really can
電
read
力を
hiragana,
提供することができるってい
katakana,
ったような機能を
maybe some
持
simple
っているということになります。
kanji.
そのロボットアームって物理的に
Yeah, I
強い
really
固
need
定す
to
るだけで
advance
はなくて、
your level.
そういったこう給電とかも行える。
Yeah. but it's fine.
ございますね。
すごい、ありがとうございます。で、もう一つ質問来てまして、僕は小学生です。物資は何が入っていますか？何が一番嬉しいものですか？これ大西さんは何が一番嬉しかったかっていかがですか？
まずどんなものが搭載されているかっていう点に関
Okay,
しては、
so
まあ
while
大体
they're
半
still
分ぐらいが実験装置です
explaining
ね
and whatnot,
そういったものが使われていて、残り
and
半分ぐらいがその
maybe rather
生
than
活用品、
making you
例えば
guys not
食事でした
understanding
り、
what,
この衣服だった
what
り
they're saying, yeah, no
生
offense
活
to
のために必要な物
to
資。
JAXA and
それが半々ぐ
Japanese.
らいで、
Yeah.
あとは
It's
先ほど
just
もちょっと
it's
紹介
just
しま
that
したけど、
I just don't want to
新
compete
鮮な
anyone
果
here.
物だ
So,
ったり野菜
but
ってい
if
う
you
のが
can
地上の方々
if you can
が搭載
understand
してく
there
れている
what
の
they're
で、
talking
や
about,
っぱり
you
そ
can
れ
go
が一
directly to the
番
JAXA
宇宙飛行士としては
stream
嬉しいですよね。
straight away
私の時はちょうどロシアの
for this explanation in
1
Japanese.
回ぐ
That's
らい
one
来たの
thing
か
for
な。それ
sure.
で新鮮な
Okay, so why not we just go here and we explore again what we do need to learn about this new HTV-X here. So you can see not really much, and this is still the initial battery they almost similar design to. You can see the the pressurized cargo there. This one is the service module, and that one that one is the unpressurized capsule there. I mean, I don't know if you can even see on the you can see my mouse, but maybe likely not, but that's a little bit thicker, don't worry. And this is how it looks like when stored. Okay, stored for launch. I mean, surprisingly, it didn't go. The design actually doesn't even change that much, except the solar panel configuration. Yeah, the solar panel configuration and how it looks like. That's the only things that majorly change. But mostly per design, it really didn't that much. So you can see how it docking and what's on. Yeah, so oh yeah. So that's why you see why they are able to make it more mass efficient design. They just remove that main propulsion thrusters which available on the HTV Konotori mission, where previously available around the bottom area, whatever is it, bottom area of the HTV Konotori there, and then they just remove it, and then they just said, hey, you know what, we might as well just consolidate it into the service cargo, where you just put 45 degrees, just let it just let the thruster just do the job instead of using main propulsion. So that's that. So they just put it there. Oh, and also it's pretty much upside down configuration, huh? That's also interesting. Yeah, and then after that, around 2017, this is now the design, and also still the same design that we saw on live previously, till this day, same thing. And this is how it looks like. 2017, 2016, something like that. You can see it didn't change the way that much. Okay. Even the CGI animation also available, but you don't need CGI in this case. You've already saw it. You can go watch back previously, or you can just wait this screen to finish and watch back on the replay side. And this is the screen grab, how it looks like. Alright, how it arrived. So this is pretty much line up to what we actually saw. Yeah. But I hope the photograph is really that good, so I can use it for the next thumbnail next time if I want to stream for the HTV-X2. Hopefully at some point in the future I'll use the real photograph version of it. Yeah, for now, at least until the thumbnail, you see I'm still using the CGI representation, because yeah, of course it's the first time, what else? So you can see there's also a little bit, you can see solar panels and whatnot. And hello if you're watching here, say hi, or if you're not saying hi, you're a little bit of shy, it's also fine. It's totally fine by me. And yeah, it's like V-shape or whatever is it. Okay, and let's see. Oh, IDSS system. Yeah, I need to learn a lot about this stuff. Yeah, I'm not going to 100% pretend understand how the system works, but it's better we learn together than nothing, right? So that's good thing about us here, and also myself. Pretty good. I mean, by the way, because I'm a computer science student, what else? Not an aerospace student, but I'm still interested a lot more with aerospace rather than computer science these days. Yeah, seriously, If I could pivot right away, I would just go with aerospace. But let's just say life has different story to me. Has a very different story. So I'm just going with computer science. Not necessarily I'm liking it, but you're just choosing the lesser worse version of it, lesser worse whatever is it. Even though nowadays, how do I say, I honestly I don't really have like the future technological users. Seriously, um, I don't have much of the positive view of it. That's sad. But okay, I guess, let's see. Is it? Oh, okay. I guess this one is also all right. Okay. Oh, okay. We'd rather just do this, so you can see. Okay, so this is how it looks like here. Mm-hmm. 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 Oh, yeah, yeah, yeah. Looks. There's even a little bit more unfamiliar term here, but that's interesting. Uh, uh, okay, also some USB propellants, gases, and gases resupply modules, mhm, and also the top. Mhm. All right. Oh, and also they are not throwing out any possibilities that maybe HTV-X will might be used for the to supply the Artemis gateway that will launch human and go back to the moon. Yeah. Oh, there is a plan H3 upgrade path. Okay, so they have plans so it can go to the gateway orbit. So requires two launches and Earth orbit rendezvous. Okay. Okay. Oh. Oh. So basically, uh, for for the mission where they will try to modify this to go to the Artemis gateway version, there's actually another interesting suggestion there. That's pretty small. How do you read? Yeah, I hope this is helping you. As you can see, this is their plan. They can go. The first step they can go is they can launch it. They can go with the two launches. First one is to launch HTV-X, and the second launches is the docking port. And then later, the second step, when they can go and upgrade, they basically will turn this into another. Guess what? Guess what? Delta for heavy esque. You can see it looks like Delta 4 heavy at this point. Just smaller edition. You can see we are going back. If they actually plan for this configuration at some point, if they make it come through, the second step, that's basically becomes the mini Delta 4 heavy. Maybe just call it Delta 4 heavy junior at that point. So you can see this is how they want to do with the only one launch. And in the third step, instead they will have the second stage and also landing vehicle integrated system. Or on the upper stage, that one is the third step and the most final step what they're going to do. Very interesting. Oh, but yeah, actually a pretty interesting proposal. I like that. That looks like Delta 4 heavy, but junior edition. I like that. I like this one. I would love to see built up or heavy like rocket something. Maybe it doesn't need to be big, but if it looks like built up heavy, I'm happy and would like to see it coming back again. Yeah, I would like to see that coming back again. Let's see if JAXA decides to bring this design at some point. Let's see. Let's not remove it out of equation, even though still in the suggest scenario. But hope for the best. Yeah, the specification. I mean, you guys already know this. I don't have to explain a lot. Huh? Oh.
っていうのを
Okay.
チームメンバ
So
ー痛感
I
してい
guess
るところなんですけれ
they're
ども、しっかりと計画通り宇宙ステー
maybe
ション
they're
に到
almost
達した
ending
と
their
いう
stream
こと
here
ですごくほっとして
because
ます。
already
で
hear
今日は
that
最後の運用のところにフォーカス
the
し
music
て、
noise.
それぞれのチームメンバーが一人一人の持ち場をしっかりと守ってミッションを、まだ道半ばですけれども宇宙ステーションに到達したという、大事なマイルストーンを達成したというところですけども、やっぱそれを達成するためにもですね、この HTV-X っていうのをしっかりと開発して製造してくれたメーカーの方々っていうのもいますし、そこに部品等を提供してくれた、ものすごく高い品質のものを、ネジの1本からですね提供してくれたたくさんの関係者の方たちっていうのの、賜物なんだろうなというふうに思ってます。本当に良かったです。
ありがとうございます。大西さんいかがですか。
はい、今日、日本の宇宙開発の歴史の新たな1ページが刻まれたなと思いますね。でこれから先 HTV-X も次に2号機3号機とどんどん成功を重ねていくと思うんですけれども、今回内山が平坦な道のりではなかったって言ってましたけれども、そういって今回苦労したことっていうのを次のミッションのために血となって肉となってどんどん自分たちのものづくりっていうのをさらに高みをどんどん目指していくっていうのがものづくりの本来の姿かなと思うので、今回得た経験っていうのは非常に貴重な財産だと思います。それをHTV-X チーム一丸となって次のミッションに生かしてもらえるんじゃないかなと思います。本当におめでとうございました。
ありがとうございます。お二人からもお話ありましたが、平坦な道のりではない中を皆さんがつないできたバトンがつながった大いなる第一歩、その本日のライブ配信の様子、JAXA 公式 YouTube チャンネルにアーカイブされます。どうぞこの感動をご友人ご家族の皆さんと一緒にシェアして楽しんでいただければと思います。本日ご覧くださった方もまた見ていただけたら嬉しいなと思います。いかがですか。
はい、今日ですね、
So
宇宙飛行士もね、未来につながる第一歩だっていうようなことを言ってくださってましたけども、もうまさに日本から、今日は宇宙ステーションでしたけれども、宇宙にある宇宙基地へこの交通インフラが開通した第一歩だなと思うんですよね。でコウノトリから技術を継承した HTV-X、ここで、5年ぶりに宇宙ステーション通算10回目ですけれども、歴史が再び動き出した瞬間を今日皆さんと一緒に、目撃できたのかなというふうに思ってます。今後も活躍の場を広げていく HTV-X、これにね注目いただきたいと思ってます。
はい、今後も HTV-X1 号機の応援どうぞよろしくお願いいたします。皆さん本日はご覧いただきましてどうもありがとうございました。
Yeah, so looks like it at the end of the stream, and thank you, and also thank you to JAXA team for the good, for the good stream. You can see there, this is the launch, and that one is the maneuver system. You can see that that cluster to adjust the altitude and there, and the soft capture just around 30 minutes. Almost 30 minutes ago, and you can see they're pretty happy there around the Tanegashima Space Center, the Tanegashima Mission Control there. And that's it, the end of the stream by the JAXA. So thank you to JAXA for hosting that one, and I've already opened the music. Nothing else we can do. Yeah, I mean, not much else people watching here, but that's very. I got very used to this, got very used to this viewership. Let me see. How do I see? Yeah, for this one. So it's totally fine. Whatever. But let's see here. Okay, so let's also finish this up. Okay. Japan will invest 760 million US dollar into the Artemis program. Okay, in the fiscal year of 2021. I mean, it's already passing. 4 years already passing. Okay, and this is how it looks like. The answer neat. Yeah, so I can say I actually thank to this guy on Pixiv and Twitter /X answer underscore neat for simplifying this information. So that's why I can read this in very good detail there. So I just use this information. So thank you so much. Yeah, indeed. And also another one you can see. And looks like also another. Okay, another render. There you can see what it's using there, here and there. Okay, this is the pressure resistance, aka leakage test. You can see, just do, and basically it's working as it tends to be. So basically the JAXA HTV Technology Center that's basically responsible for the development and operation of stock, basically already disbanded 4 years ago, and then replaced with the automatic docking technology demonstration project team for the demonstration with the HTV-X2. So we are going to see that team would be coming back again from the disbanded team of the HTV Konoto V1. They will be coming back again for the HTV-X2, if I read this correctly. So yeah, pretty interesting. Alright, and this is how it looks like, the mission patch. Okay, team version attach. Yeah, but I've already cleaned it file before. Also pretty interesting. So thank you. And this is the slides for the HTV-X1 and also -X2. You can see what does there on the technical demonstration of on the HTV-X1, what they will do. Okay, and also for the X2 later, we are going to read this one. Of the presentation, you know the technical presentation. You see the IC, you can see, and also the light, and also they're also on the HTV-X1 demonstration. They are going to demonstrate the small satellite deployment. Okay, directly from the HTV-X1. And also you can see the SLR, the satellite laser ranging reflector. It's using the laser ranging to determine the distance and also the velocity between the International Space Station and also the HTV-X1, of course. And also if we read another slide here, okay, and apparently ICIP also stands for the IVA replaceable small experiment platform. So basically it's the experiment platform there. And also the light actually stands for deployable lightweight planar antenna technology demonstration systems. And for the IVA, of course, it means intravehicular activity. IVA basically like activities happening mostly inside the ISS, and also in between these two launch vehicles itself. So basically like that, they are not going outside. So you can see how it looks like before, while it's arriving, it's using the ISIP technology, to do a bit of experiment here and there before it reaches to the space station. And of course, it's using the lidar for the demonstration too as well, so it can calculate the distance and velocity in between the international space station and also the HTV-X1, of course, you can see. And also for the demonstration of the ISIP to transfer unpressurized cargo with the ISB robot arm doing ISS berthing setups. I believe so. That's how it fits. And also the small satellite deployments for around 1 week after arrival. Yeah, we have already seen the arrival and capture and arrival to the International Space Station, which will be berthed into the Harmony Nadir port. It will be okay. I'm a little bit off wrong. What am I even talking about? Okay, the small satellite deployment, it will happen just basically around a week after departure from the International Space Station. So we deploy the small satellite around 500 kilometers max altitude, and also it will test the ground station, okay, the telemetry, conventional, whatever is it, and also it's going to test the laser ranging with JAXA SLR reflector. Okay, for the SLR ground station, it will relay to the how do I say, to the HTV-X1. It will test that out for around 2 to 3 weeks, and also for the Delight, it will test out for 2 months there. Oh, so apparently I'm a little bit wrong there, but hey, it's fine. It will test it around 2 months for demonstration for the deployment of deployable lightweight planar, lightweight planar antenna. You can see the planar antenna. It looks pretty interesting there. I mean, speak about the planar because in the in the microchip design, something like that, also have planar design, so I can sort of relate that word as the planar. And also receive radio frequency with deployable lightweight planar antenna, and also next generation solar cell that also tested out between the ground station and also the planar antenna to verify the uplink for sure. And after that, after around 2+ months, maybe even 3-4 months after that, then it will be destructively re-enters back to Earth to be destroyed and also to be peacefully retired among the fishes around the Point Nemo Pacific Ocean. Basically, no one's 99.99% no humans there, and even if there's fishes mostly like don't care, or hopefully they care enough to be very, very careful. Okay, and also this is the for the HTV-X2 technical demonstration. So apparently for the X2 version, it will have the docking system as the demonstration for future missions, such as the manned Cislunar Station Gateway, which is planned in NASA Artemis program. So you can see they are also going to demonstrate this one too. And you see here is the slide there, the docking system. Okay, and this is the render version. That's one thing for sure you need to know. Okay, so I'm going to finish up as much as possible because I too really wants to sleep. And here we go. This is the team, the participants and whatnot. Okay, Uh-uh. Huh? Oh, so the JAXA docking system apparently is a joint project between JAXA and MSI. MSI actually stands for Mitsubishi Heavy Industries. So basically, could be it. Oh, yeah. And also, the subcontractors could be Boeing, or maybe even Energia, Airbus, DS, or maybe even KAS. That's one thing's for sure. Oh, domestically developed using the ISS MCB developed IDSS documentation. Very interesting. Yeah, and also this one is, of course, the official JAXA's astronaut Twitter/X account, Kimura Yui. Yeah, interesting, isn't it? Yeah, it looks like going to the port, going to the Tanegashima Space Center, and then it arrived. Okay, loading, unloading it. Okay, so space development. And you can see this is how the stacking looks like. The complete, how do I say, the complete version of the complete thruster package compartment for the HTV-X1. You can see, pretty interesting. It's basically 45 degrees, and you can see it's all of it were tested beforehand. You can see really 45 degrees. Interesting there. Everything were tested before integrated for sure. Oh. Oh, so that's also video. The conversion and modernization of the former HTV MCR for the handover for the HTV-X. Oh, interesting. Okay, this is the previously HTV one, and also, of course, there are some information that we like because a little bit for stuff, and also some proprietary information and some that that's supposedly should see, I guess. Okay, so that's pretty interesting. Right, so this is how the template looks like. Okay, maybe I should just turn off that music, just in case. Okay, so looks pretty interesting. Oh, yeah, conversion and even modernization. It looks nice there, even on the construction. Oh, yeah, you can see. This is after. It looks modern, right? It looks modern, doesn't look decrepit. And it looks nice. That's one thing for sure. Yeah, so that's it, guys. That's what we need to know about the conversion room of the mission control center there. Oh yeah, mission control room, MCR. Yeah, so that's, you can see. This is also another stacking one. Preparation, safety, whatever is it you need to know. And of course, it's like, okay, that's it. Okay, CSS, the unpressurized cargo support system. Oh, so SME service module. I need to get myself more familiar with the aerospace wording here, because I'm I'm very interested to keep up with this, even though I'm studying computer science. Okay, and yeah, and this one is the exclusive body clear also, of course. Oh, so this one is the propulsion module, of course. This is where she visited there and watch it. After all, okay, this is up close of it. Oh, so also open media there. Okay, and the rest of it, the journey delivered to Tanegashima on 17 January 2025 this year. Oh, yeah, I just fully specified the year in case you watch this replay years ahead or even months ahead of this one. Maybe in case New Year's, you still know this is 2025 we are speaking about. And you can see here. Okay, open for media. Let's see. Okay, another thread. So this is also how it looks like. Okay, and HTV-X is in contract for 5 missions. So after this HTV-X1, it's basically 4 missions to go. Okay. Alright. Maybe let's go check HTV-X1. Maybe. Oh, alright. Looks like I need to type it in here. HTV. Space slide for them. Okay, maybe they have a little bit. Oh no. Oh, here I need to put it up here because sometimes they will specify a little bit what we don't even have information. So using procedures like that. Here you can see. Here, Okay, let's see. Are there anything that I need to note here? Okay, this one not needed. We know this what happened. Oh, alright. Yeah, the approach ellipsoid and also keep out sphere. You can see this is the zone here. Let's see, because usually they have information here that I can use. Okay, so I can tell you a little bit brief what this HTV-X1 mission actually all about. Yeah, and also I'm using render by the staff member Mac Crawford. Yeah, macro fort from NASA space flight, of course. That's how I use it. I use this one because it looks really actually beautiful. I tried to use the JAXA render one, but not really as good. And also the same can be said with MSI, the Mitsubishi Heavy Industries, not as good as this one, so I just use this instead. Yeah, looking pretty beautiful, good, and it doesn't differ that much from in real life. Although maybe slightly different is the, well, at least from this view, the curve of the at the end of the nose cone. It's much more smoother compared to the render itself, but still pretty close, I can say. Yeah, pretty close. And let's go. Is there another stuff we can also learn here? Okay. Oh. So apparently also they have the HTV-X space diary too, but of course in across the accounts of official accounts of JAXA, MSI, and also Mitsubishi Electric. That's also another one there. Okay. Ooh. And also even this account as well. The human space underscore JAXA. Damn. Mated inside the payload frame. And actually it's pretty funny reading the video. I like this. Oh man, I really like this. Yeah. See. Oh, fruits. So apparently they also send fruits such as apples here to the astronauts in space, especially specifically for Yui aboard the ISS. Yeah, so interesting. And also, back then they did the propellant loading, to the service module. And also loading of the whatever cargo inside the pressurized module, aka also known as the standard cargo, not the typical, nothing burger cargo, of course. And then yeah, electrical test. Interesting, yeah. About weather, but not so much else too weird here. Oh, so apparently they also have the task TUSK PM, the aka known as the test facility for lab automation system in Kibo. They're testing out for the they test out for to analyze errors caused by microgravity on precision equipments, and basically to realize automation and autonomous technology in space also, and also remotely operates the manipulator inside the Kibo module, and yeah, evaluates accuracy, comparing it with the ground-based operation, so they can see whether or not this is accurate and whatnot. That's why you can see the roadmap map before. Okay. Okay, also another fresh food. You can see how they prepared it. Here, they prepared it very carefully. This is very specific for the astronauts on board of the ISS. Not the kind of typical food to eat. So they also bought tomato here. Oh, so apparently also tomato or tomato, whatever you would like to call it. Yeah, apparently tomato and also apple. Wow, interesting. I like it. Oh. Oh, and also the pressure cargo layout, but this is specific for the old HTV missions, but yeah. Oh, but that's plus minus how it looks like inside there. And lastly, to end this stream, because of course I really want to sleep too, and almost approaching 2 hours of stream, so around 1 hour and 30 seconds of stream, so might as well just go as soon as possible. This is how it looks like. Okay, and also delivery from Tanegashima Space Center, Japan to ISS orbit. Yeah, you can see like the shipment barcode there. Activity report. Okay, how it looks like. Okay, the integration, how they integrated inside the payload, inside the capsule, inside the fairing, inside the fairing shroud. Okay, like a protective armor, some like the Twitter/X post says there. Pretty interesting. Oh, also include water resupply tanks also for the pressurized cargo. So basically approximately around 2 metric tons there inside. Oh. Oh, so it would be so okay. Pretty interesting. That's how you prepare back then. Oh, so apparently also there's also NASA personnel or come to complete the work at Tanegashima, which also to install the nitrogen and oxygen replenishment system, nose tanks, handed over to HTV-X and loaded as pressurized cargo, and it's being and will be used to maintain the air in the ISS after arriving at the ISS. So you can see after it arrives now, it just uses the nose, nitrogen and oxygen replenishment system. So you can see for sure. Okay, so even has its own cargo rack inside the pressurized module there, also known as dedicated racks there. Oh, pretty interesting. A total of 8 dedicated racks are installed in 2 rows, both vertically and horizontally. Yeah, pretty interesting. And also for the technology demonstration platform, as I've already told you before, they have the SODE Mount Fuji, not to be confused with real Mount Fuji, of course. That one is for laser ranging, LiDAR technological test bed there, and also D-Light/SDS for sure. Carry out over the 3 months. You can see. Yeah, and also the Nihon University's Tenko, I say Tenko 1, right? My mistake. It's actually Tenko 2. Apparently, yeah, Tenko 2. Tenko 2, yeah. This one will be deployed later around 500 kilometers. So that's one thing for sure. Tenko 2. Oh, Ivory characteristics. Oh, sorry guys. I think we are almost near, and after that I'll just go and sleep. Okay. Mission overview of D-Light and the footage, CG, quality visit. You can see this is D-Light, LPA, STX, yeah, DLP, whatever you want to see here. If you're very interested, you can also read this one. Maybe I'll put it in the comments, in the description after probably when I have time by tomorrow, like that. So yeah, here's another one, the next generation space solar cell on orbit demonstration SDX. Oh, okay, so this is the solar cell, so the new generation there. That's why it's called SDX. Measure the output of the Phoenix solar cell, and they tries this to achieve the ultra high efficiency with an origin structure. Oh, perovskite solar cell. Yeah, I know perovskite technology there. Pretty much recently on the rise, you know. And also a small reflector Mount Fuji for the SLR, the satellite laser ranging mission, which will test around the 40 SLR ground station around the world, and they test it to compare it with the telemetry of the HTV-X1 unit there. Okay. Oh, okay. So basically, what the HTV-X1 actually improved is it says here, enhanced transport capacity, which the mass increased from 4 metric tons to 5.85 metric tons, approximately 45% increase, and also volume increase from 49 cubic meters to 78 cubic meters, around 60% increase. Of course, significant improvement over the Conatory, the previous HTV1, previous HTV, you know. And yeah, it will be grabbed by the robotic arm and docked with the Harmony nadir module. Okay, new technology, whatever, and also it's going to be a technical demonstration for the life support system, such as the CO2, the carbon dioxide removal system on orbit demonstration, DRCS, and also to establish JAXA's proprietary technologies. Basically, only their tech can be used here. Oh, okay. So this is basically their press kit for the HTV-X1. Oh, this is in Japanese. Okay, and this one is is the translation one. Translated, not sure which. Oh, using the online. Okay. This one is the translated version. Okay, of course, if you're very interested, you can read this at some point. It will be too much. Okay, see what it actually looks like. Okay, and also when it's stacked on the onboard the H2 rocket, H3-24W, of course, and this is how it looks like loading there, and the RCS installed on keyboard. Okay, the CO2 removal system there also available there. Oh, the RCS actually stands for demonstration of removing carbon dioxide system. Okay, that makes sense why it actually calls as DRCS. Yeah, DRCS. Yeah. Okay, the fairing. Yeah, for this fairing, if I remember correctly, this specific fairing were manufactured by the Beyond Gravity, aka old name would be RUAG Space, RUAG Space. Yeah, so that's the company that actually manufactured this specific one. But the rest of it, if I remember, for the long and short variant, that one is manufactured by the MHI themselves. MHI and also another one, if I remember correctly. But that's all. I guess that's a bit many to explain, and we are now in almost 1 minute and 40 seconds into the stream. I guess I can go and end my stream here. So yeah, thank you so much for watching this HTV-X1 docking mission to the ISS, which was successful. Yeah, around an hour plus ago. Thank you so much for watching, and yeah, I hope I can see you guys later for the stream, especially the nearest one. I can definitely I definitely cannot previously I said that I can go stream for the SpaceX's Falcon 9 rocket for the mission of Transporter 4, right? Unfortunately, I can't, because around that time, well, some personal stuff here and there, and also because mostly from what I can tell, not many people are actually interested with the Falcon 9 rocket in general. And even then, I already saw there's already too much people stream here and there about SpaceX. So usually if it's Falcon 9, usually I can go and not really care too much if I want to stream it or not. Plus mostly because there's like because there's also Korean military satellite onboarded there, so obviously it's not going to be very interesting to watch. So I just leave it right there. Maybe I'll stream it next time. Maybe if there's Transporter 5 mission, maybe I'll try. But other than that, if the missions like that, I will just stream one time only for the for both the bandwagon and also the Transporter mission, and after that I'm not going to stream it anymore, because just like the Starlink, it's basically plus minus almost common, so I'm not going to stream more after that. And also, yeah, remember that I also stream about the Starshield. I don't plan to stream it anymore because it's also pretty much plus minus the same, and I don't want to bore my audience with the same stuff, same fitting stuff for the SpaceX stuff. So I rather not stream too much. So yeah, but definitely I can go and stream the ISRO's LVM-3-M5 mission. You know, the launch vehicle Mark 3 mission, which will carry the replacement mission GSAT-7R. Yeah, GSAT-7R, aka the aka what's another name there? Never mind. Because I just don't want to be a fool, not remember the name. But for one thing's for sure, it will be a replacement satellite for the Rukmini satellite, which was launched as the GSAT-7, aka also known as the INSAT-4F mission on board the Ariane 5 ECA rocket there, from Kourou, French Guyana, the Guyana Space Center, of course. So that's also interesting one. One thing's for sure. Okay, definitely I can try stream that. And if, let's say, also if InnoSpace plan to stream their stuff at some point, I'm ready. I'm also open up my stuff there. That's why. So that's that. And yeah, thank you so much for watching. It's already 1:05 around. It's now 5:30 a.m. here, local time here in Sarawak. It's of course 30 October 2025 on Thursday. So I just want to get some sleep, and also because I need to chase my bus for sure to go to university. So that's all. Thank you so much for watching. Okay, and this is my trademark word here. So this is Suguwa signing out, and thank you so much for watching. Take care, everybody. Goodbye. And yeah, of course, nothing else for you to watch here behind the scene. It's already finished. Bye bye. Take care.